Alright, today's project is going to be a PVC sheath insert for my brother's knife. It has a cheap nylon sheath, and he's worn it so much that the tip has actually worn a hole in the bottom of the sheath. Starting out here, I've got a piece of, I believe, Schedule 20 PVC. I just cut a random length of it that I figured would be long enough and then split it down one side. I'm going to nail in it here to try and help split it open, but you'll see in the video here it didn't really do what I wanted it to do. Alright, you'll see me here heating up the PVC with my heat gun. My heat gun has two settings. There's a 500-degree setting and a 1,000-degree setting, I believe. I should have used the 500-degree setting, as the 1,000-degree setting went a little quicker, but you'll see the PVC starts to turn a little bit brown, which means I was burning it, and that's not the best for it. It shouldn't matter with this project, seeing as how it's all going to be inside of the sheath, so you're not going to notice, and we're not really hoping for a whole lot. That's not going to be any stress put on it, so the structural integrity shouldn't be compromised that much. As I started to get the PVC malleable here, I got a 2x4 out to help spread out the PVC pipe and kind of start to give it to the shape I wanted in order to cut it to size. You'll also see here that it got a little hot, and I put on the gloves that I should have probably been wearing the entire time. So make sure you do that before you start this, because the PVC does get very hot and it can burn you, as well as the heat gun. And it's just more heating and shaping. You basically want to heat the PVC pipe up until it's completely malleable, and then once you have it to where it's basically, should flop around, it should be pretty flimsy when all is said and done. You want to clamp it between another board, and the idea here is to create one flat piece of PVC pipe that we can then use to cut out the shape we're going to need in order to create the insert. Once you get the PVC clamped, give it a few minutes to cool off. After 5-10 minutes, it should be cool enough to take out of the clamps, and you should have a flat piece of PVC that we can use to create our insert. Next, we traced out our pattern onto our PVC. We used a piece of cardboard that we had cut to the proper size. We got the proper size by making it the width of the sheath and then twice the length, and then we just trimmed it down until it would fit inside of the sheath folded over, and that's how we knew the proper size for our PVC. And then I just traced it out, and I used my radial arm saw to cut it, but you could also use a hacksaw or anything that'll work. Here I am kind of test fitting it in the sheath and gonna trim it down a little bit. As you can see, it's the sharp corners don't really slide in very well, and so we're gonna need to do some fitting. Here I am using my tabletop grinder to kind of profile the insert and round over the corners so that it'll fit into the sheath a little better. I probably should have been wearing gloves for this. You should wear gloves, do as I say, not as I do. I was wearing safety glasses, so at least that part of me was safe. Basically just need to trim this down until it'll easily fit inside of the sheath. Once you have it profiled so that it'll fit in the sheath, the next step is to find the center point of the insert, and then we'll start heating it back up. As you can see here, the insert will be just a little bit longer than the knife blade is long. Here you see me heating up the PVC again. You'll notice I focus on that center point where the fold is going to be, but you need to heat up the whole thing because the whole thing needs to be malleable. It's going to take a little bit, but when it can't support its own weight, that's usually a good sign that you're ready to go on to the next step. Here you can see me using an old t-shirt to kind of create my form. If you have a piece of foam, or heat-resistant foam, that's better, but this is all I had, and it worked just fine. Once you have the knife inside of the insert, just clamp it down and then wait for it to cool. Once it's had time to cool down, take the knife and the insert out of the clamps, and you'll see that we've got more or less the final product here. It does have a right and wrong side, so make sure when you do this that the knife blade is going to go the right way in the sheath, the side you wear it on. But you'll also notice here that now we fold it over, it's a little too big to fit inside the sheath, and we're going to have to do some more profiling. Here we are again with my little tabletop grinder, and what we're going to do is just grind down the edges and the corners a little bit until it fits inside the sheath. Don't get too crazy because you still want it to be robust, and the thing that we're really looking for in this particular insert is we want the bottom where the point is to be nice and thick so that it doesn't protrude through the bottom anymore. Also to note, we sewed up the hole that was in the nylon sheath before we started, so we didn't have to worry about that either. Once you've shaved down enough to where the insert will fit back in the sheath, you're pretty much done. You just put the knife in and you're good to go. This particular one was not tight enough to friction hold the blade. Maybe if we'd have used some Schedule 40 instead of a Schedule 20 pipe, that might have helped. I'm not real sure. I didn't have any wide enough Schedule 40 pipe on hand, otherwise we might have tried that. But for about 10 minutes worth of work, this sheath is pretty much ready to go again for him, and it's a lot safer than it was when he bought it. He uses this knife pretty much every day at work, so the sheath has seen quite a bit of abuse, and he's had this for a good 2 or 3 years, so I'm surprised the nylon lasted as long as it did. But if you like this video, please like, share, and subscribe.